Hi everybody. Today in this video I'm going to talk about the function fx equals absolute value x squared minus 16. So when we do some investigation of analysis of external functions, we sometimes face up with some problems when especially we have a difficult type of question, or especially this is the function which involves absolute value. In this video today we are going to analyze such a function, and we are going to see how to deal with, in general, with absolute value functions. So before that, let's remember what's the definition of absolute value. So absolute value of x is defined as positive x if x is positive. It is zero if x is zero, and it's less minus x if it is x less than zero. So this is the general definition of absolute value function. And this is the graph. And from the graph, you can see that the function gets its local minimum at point 0, 0. So, but anyway, we know from our lectures that the derivative at that point doesn't exist. So today we are going to apply the derivative and try to find the external points of this function. For this purpose, let's write our function in expanded form. So fx equals to x squared minus 16. If this function inside is positive, we get x squared minus 16. If it is equals to 0, we get 0. And if it is less than 0, we get negative x squared minus 16. So obviously, in more detailed form, we are going to get this expression for our fx. Now, let's remember which which points we call the extreme points of the functions. So if we are given y equals to fx, then obviously if c is the critical point, then at this point, f derivative c should be either equals to 0 or f derivative x doesn't exist. Doesn't exist. This is a very important part of the research because students usually forget about this because at school this problem is not analyzed. But here we are going to do this analysis with this function, and you will see that when we apply this, we get the results. So again, if you remember in our lectures, we said that the derivative of function y module x at point x equals to 0 doesn't exist. So we know why, because module x doesn't have the derivative, it has got the left derivative at 0, which is -1, and right derivative, which is 1. And it's seemingly at point 0, left and right limits do not coincide, so they are not equal. That's the reason that the derivative as a limit does not exist there, so the function is not differentiated at point x equals to 0. So this is the fact that we are going to use for this case. So let's find the derivative of f. So f derivative x is equals to, we are going to use these notations here. So it's going to be 2x if x is less than -4 or x is greater than 4. If x equals to plus minus 4, you see plus minus 4 makes this function 0. So we said that 0 modulo x doesn't have the derivative. So the derivative doesn't exist. And if x greater than -4 and less than 4, then in this case, we are going to have -2x. So equalizing it's 0, we are going to get here point x equals to 0. But we shouldn't forget x equals to plus minus 4 can also be the points of extremum because they are already critical points. So now, how we are going to investigate? We are going to use the mostly used method here, which we call the interval method. So we are going to organize the sign chart here for these numbers. So we have -4. So we don't have any problems with these points because at 0 and plus -4, our function is defined, it's continuous, so there is no problem with them. Also, the derivative doesn't exist at plus -4. By definition of extreme point of critical points, we have to take into them consideration. So we divide our real x into these four intervals, and let's do the test here. Let's do the chart, sign chart. So greater than 4, we get 5. So you know 5 is bigger than 4, so we are going to do here. So 2 times 5 is positive, we get the positive sign. Between 0 and 4, let's take any number, for example, 3. 3 falls here, you see, in the last one. So it's going to be minus 2 times 3 is going to be minus sign. So between minus 4 and 0, we are going to get minus 3. So minus 3 is again falling to this interval. You see, it's greater than negative 4, less than 4. So minus 2 times minus 3 gives us the positive value. And less than 4, we get any number. For example, let's take it minus 5. Minus 5 falls in this interval, so it's going to be 2 times minus 5 is going to be negative sign. So we see here that the signs change from negative to positive here, and from negative again to positive. So obviously these points here, minus 4 and 4, they are local minimum points. Minimum points. Now, what about point 0? So in this case, it is, you can see at 0 function increases because the derivative is positive and then starts to decrease after 0. So this point is the point where the function gets its local maximum point. So our analysis here gives us the following. So we can finalize that function fx equals absolute value x squared minus 16 gets its local minimum points at minus 4 and 4. Obviously, it is 0. And at point 0, it gets its local maximum point. Again, its local maximum point, it's not the global one. So we shouldn't mix these ideas here because the function, is this function has got the infinite tendency when it extends to infinity. So we are not going to get here a global one because every time it increases, the number is bigger than the previous one. But this is 0 is local extreme, and we know by definition what's the local extreme point, as it is the point where in the interval, which close interval of 0 or close vicinity of 0, the function gets its the biggest value, which is 0. That's why we call it local extreme point. So guys, I hope this video was useful to you. I'm going to also upload some other videos. These videos will be useful, I'm sure, for you for your exams. And I wish you good luck in upcoming finals, and take care. Do not forget to leave your comments, also to leave your request on topics which you feel that should be explained once again. So hope to meet you in our next videos. Take care. See you.